So good morning everyone. Welcome to the lecture 10 on the course Data Structure and Algorithm. So today we shall start with single linked list. I'm sharing my screen. Hope all of you can see my screen. I think my screen is visible to all of you.
Yes.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
So in later section, I mean at the towards the end of the course, we will learn about understand about graph. Okay, so already in circuit theory, you will be introduced in, you have been introduced with graph, no issue. So suppose this is a graph. Graph means, okay, we call this actually as a vertex. Node and vertex are similar thing, just terminology is different. In case of graph, we call this as a vertex, but in case of other data structure, let's say, I mean tree or this linked list. Okay, so this element is called actually as a node. So this is a vertex which is containing some information, some data. Let's say integer data. So let's say here some value 2 is stored, and here some value, let's say 6 is stored, and here it's 4, 8. Okay, so these require some physical memory allocation. Okay, and suppose we have something like this. Okay, so this is actually a diagram which is more specifically known as directed graph or simply digraph. Okay, digraph or directed graph. So these are vertices or vertex. 2 is a vertex, 6 is a vertex, 4 is a vertex, 8 is a vertex. And in analogous manner, if we try to sketch the diagram of a single linked list, then it will be looking like this. Okay, this is containing 2, this is 6, this is 4, this is 8. These are called nodes in case of single linked list or linked list, simply linked list. So also this is the linker part. This is the linker part of each node. This linker part is connecting this node and this node like this. This linker part is connecting these two nodes like this, and this linker part is connecting and this is the last node, so it is not connecting any other node available in the list, so it is connected to null. And overall this is a single linked list representation. Okay, so for easy visualization purpose, this is the diagram, simplified diagram, which is more technically known as a graph, directed graph, and this is a corresponding linked list representation. And as all these elements, in this case, these elements are known as vertices, singular form vertex, plural form vertices. Here, these elements are known as nodes. Okay, these nodes are not simple primitive primary of primary data types like integer, float, character. Okay, So these nodes or these vertices are nothing but structure structure variables. Okay, so or simply structures. So as they require physical memory allocation. So they will have their own memory addresses. Let's say consider this is 2000H, and let's say this is 6000H. This is, let's say, 4000H, and this is, let's say, 8000H. Okay. Similarly, this is of address 2000. This is of address 6000. This is of address 4000. This is of address 8000. So this linker is nothing but a pointer, and this data part is nothing but a simple variable. Simple variable. It may not be like a simple variable. Here we are assuming that the template of the structure corresponding representing a node is like this. Start. Let's say it's a single linked list node, int data, start SL node, start linker. That's all. So this is our template definition. How will a node in a single linked list be look like? Okay, or be defined. So this is your template definition of a node. Okay. Okay. So now, yes. So struct is a node. So this is the data part. The overall this template is representing a single node of a linked list. Okay. And what is the definition of a node? The definition of a node defines that it is comprising of two parts. One is this part represented, defined by int data. So one is the data part. We call that part as a data part, and that data part is nothing but a simple integer variable. In my case, in our case, what we are discussing about. So this may be int data, this may be float data, this may be char data, this may be some array, int array. Okay, this may be a file. Okay, this may be some another structure. Anything it can be. This is your information. And the second part is the linker. So this can be anything, any variable. Okay, but this should be a linker or a pointer, simply a structure pointer. Why structure pointer? Because by this notation, star linker. So linker is the name of a variable, and as just before the name of the variable, we are putting a star. So due to that, star linker makes us understand that it's actually a pointer declaration. Int star linker, it's an integer pointer. Float star linker, it's a float pointer. Char star linker, it's a character pointer. So by this notation, star linker, we mean by that it's a pointer variable. And what type of pointer variable? What is its data type? That is defined by this thing. This thing. Okay. So if I replace that thing by int star linker, that means that linker pointer variable is of data type int. If I replace that by if I write like this, float star linker. So linker is a pointer variable which is of data type float. Similar to this, if I mention like this, struct SL node star linker, means linker is a pointer variable which is of data type struct SLL node. And how we come to the conclusion that its data type will be struct SLL node, that is, linker is a pointer which is pointing towards another node which is very similar to each of these nodes. In this linked list, all the nodes are of same data type. Or of same template definition. Okay, this node is having definition defined by this definition. This node is having this same definition. This node is also having the same definition. This node is also having the same definition. So definition can be changed. Definition can be, this is a user-defined definition. You are defining the node definition. It is not absolute or standard. This can't be changed. No, it can be anything. You can define. I can define my own another type of node. Let's say start DLL node, start DLL node, double linked list node. Let's say okay. Let's say int data. Okay, and let's say start DLL node star prev. Okay, and start star next. I may define a template definition of a node in a linked list like this. So this is another new definition. Whenever, so definition, this is a structure definition. This structure template is having some name. What is the name? This is the name of the structure, SLL node. This is the name of the structure, DLL node. What are the elements inside the structure? There are two elements in this structure, inside the SLL node structure. Those are int data. Another element is struct SLL node star linker. So these are the two elements. This is the name of the structure. This is the name of the structure, and here we have three elements of this DLL node named structure. So their template definitions are different. Okay, and this will be somewhat looking like this. Something like this. So this is the data part. Okay, this is a linker part. This is another linker part. This linker part is supposed to link the previous node. This linker part is supposed to link the next node. So this is the template. So whenever you change or define your template accordingly, it will be the structure of a node. Okay, so I'm reviewing this part. I hope you have understood. Now in our context, so all these nodes are of similar data, similar definition, this definition. Okay, so any linker part inside a node is pointing towards another node which is of same definition. Same definition means what is that node name? Node name is SLL node. So all of these nodes are having a particular definition name, that is SLL node. I'm writing here, definition name is SLL node. Okay, and accordingly, okay, elements, there are two elements. Those are data and a linker pointer. These are two elements, structure elements we call them. Okay, and next okay, data type of those elements. Data type of those elements, what are their data types? So for data variable, the data type is int, simple int, and for linker variable, the data type is struct SLL node together. Not only SLL node, not only struct. Struct is a keyword which is used to define a structure definition. But so structure is a keyword, is a reserved word, and it is already defined accordingly. So what is the purpose of struct? So using struct keyword, you are trying to define your own definition. So that means there should be some unique name or unique identity of your own defined structure. What is that? That is the name which you have provided here, SLL node. So struct SLL node together will define your name of that definition. Okay, so linker is a pointer variable which is pointing towards another node which is of data type struct SLL node. Okay, thereby data type of that linker becomes struct SLL node. So likewise, for example, int star p. Okay, so p is a pointer. So my question is, what is the data type of this pointer p? So the pointer P is pointing towards a variable. What is the type of that variable? Int. That's why the data type of this pointer P becomes int. So the data type of a pointer is defined by the variable towards which it is pointing. So here the linker pointer is pointing towards a node which is of data type struct SLN node. That's why the pointer data type becomes struct SLN node. I hope it is now very clear. If you have any doubt, you can ask me. Okay, so this is the picture so far, and let's so taking this example, let's try to create such a single linked list. Okay, so this is our logic and our diagram. Now we move towards implementation of the single linked list. So first we shall start with algorithm. Okay. Before starting of the algorithm, let's mention what are the different types of operations we may perform on a single linked list. So operations on SLL. Number one, yes, insertion of a new node. I think it is having some cases you may insert at beginning position. Okay, you may insert at any intermediate position. You may add that new node at end position. Okay, so then you may have you may apply deletion operation. You may perform deletion operation, deletion of a node. Again, you may have options like by value or by position. This is recommended, and then you may go for traversal in list, and you may implement some features based on traversal technique like display list. Then you may go for count list, count the number of nodes in the list. Then you may go for uh, search a node in the list. Okay, so these are the fundamental operations which you can perform on a single linked list. So let's start with insertion of a new node at a beginning position. Okay. Okay, let's draw again. Okay, so before okay, now we do not have any single linked list available at this moment. At any time, I have to do insertion of a new node at beginning. So you may assume, you can't assume, okay, there is already a single linked list available. Okay, some nodes available in the list, or there may not be any node available in the list. The linked list is empty. Okay, so both the thing you have to handle in more generalized way. So we are going towards that approach. Insertion of a new node at beginning. Okay, so let's handle the first case. Okay, the situation is the linked list is empty, nothing is there. Okay, so here what you have to start with, there must be a pointer which is first. For example, I am giving the name of that pointer as a first. So as this pointer is supposed to point towards a node, so its data type should be something struct SLL node type. So we are using the same definition of the node of a single linked list, that is this one. So we are using the same definition: start SLN node int data start SLN node star linker. And as per that definition, the data type of this pointer will be start start SLN node and star first. Okay, simple. So this is going to be one of the pointer which we have to use throughout the operation on single linked list. So the job of this fast pointer is is to point towards the first node anytime in the list. Okay, so this is the dedicated role of the first pointer. Okay, next we will use another pointer, okay, of which name is temp. Whenever you are trying to create a node, someone has to hold that node. So you are trying to create a new node means you are trying to allocate memory for that new node. So someone should point towards that node. Otherwise, you can't access the node, right? Someone has to hold that. For example, int x equal to 5. So if I want to access that value 5, okay, so I have to use that variable x. Through the help of x, you can access that value. You can display that value. Printf percentile d x, like that. So you need some variable who is storing that new node, so newly created node, okay, so that you can access that node by some variable. So let's say temp is our variable through which we want to access the newly created node, okay. And as this pointer is pointing towards that node, so I just want to ask you, what will be the data type of this temp variable? So this is going to be a pointer. Why? Because this is pointing towards a node. So but we can't, in C language we don't have any variable data type who will be directly pointing towards a structure. Okay, so as it is pointing towards the structure, basically it is holding the address of that structure. So this is supposed to be a pointer. So if temp pointer is pointing towards a node of this data type, so tell me what will be the data type of this temp. How should I declare this temp variable? Temp pointer variable. Yes. Raise your voice. Anyone?
Struct
SLL node.
LLN node.
Yes. Anyone? Louder.
So
Anyone?
Struct SL node.
SLN node.
Start SLL node. Then
Start
Star temp.
start. Right. So start SLL node start temp. So this is your data type. Okay. And what is this purpose? Its purpose is to hold a newly created node at any time. Okay, at any time. Okay, fine. So at the start of this operation on linked list, we don't have any node. So the first should be pointing towards null, right? So first should be pointing towards null. So first equal to enumerable. We can do this. Okay. So that means null of which ASCII value is 0. I am assigning that null inside the value of first. So in terms of memory, what will be the picture? The picture will be looking like this. So suppose this is the memory allocation of first pointer variable. Its name is first, and inside which, okay, so inside which there is some value that is null. So diagrammatically, what it is looking like, okay, we can draw. Diagrammatically, it is Right. Right. So this is the diagram. This is the picture of the linked list at this situation. Nothing is there. And first is pointing towards null. Okay. Now I'm prompting the user, please provide a value so that I can create a new node and add it to the existing linked list. So this is our one of the situation where linked list is empty. So let's say user is giving a value, let's say a 2. Okay, so some,
Sir,
yes,
sir, so in order to check whether the linked list is empty or not, so we have to confirm that first a double equals to null, right?
yes, it is
For
very
checking.
simple. You just check whether first is equal to null or not. So if it is visible, if it is true that first is equal to null, that means linked list is empty.
Linked list is empty.
Okay. Otherwise, if there is existing at least one element, at least one node in the linked list, first will never be equal to null. First will be pointing towards address of that first node.
First node, yes.
Right. Okay.
Okay.
So yes, we can add a comment over here. First equal to null, signifying that the list is empty. Okay. You can use this condition at any time to check for the linked list is empty or not. So now let's say user has given a value, let's say 2, and this overall, and it will have its linker part. What it is pointing towards? It is pointing towards nothing. You have done nothing. Just you have stored 2 inside the data part and you have done nothing in the linker part. So it is pointing towards nothing. So nothing means any garbage value or null, whatever. So now this new node which is being created, it will have its own memory address. Let's say its memory address is 2, 0, 0, and 0. And I told you that a newly created node must be pointed by a pointer called temp. Let's say here temp is there, and is supposed to hold the address of the newly created node, that is 2000. Okay, so that this pointer temp is pointing towards this node. Okay, so if you want to create a new node, this will be the picture. Okay, so how to create, now let me go one by one. How to create such a blank node? Blank node means, suppose this is not there, blank node. How to create code for that? So some equal to, it's about a memory allocation of this node. So you can use that malloc function to start SLN node star. Okay, forget about this thing. Okay, so malloc, what amount of memory size you want to allocate for this node? You don't know. So that means what is the memory size of this structure? What is the memory size or allocation for this structure? You don't know. So how to get that information? What will be the memory size required for this structure? So you use that size of operator, and here you have to provide the variable name, size of data type name, size of int, size of float. So what is the data type of this structure? Struct SLL node. So here you have to provide struct SLL node. So if you provide this line highlighted portion will give you the number of bytes. Let's say 32. Let's say 48. Something like that. So okay. So this is the syntax to create a memory allocation for a new node, blank node. That's all. Then semicolon. So by this code, some 2000 memory address will be generated. Some 2000 memory address will be allocated for this type of blank note, and someone has to refer this. It is not yet done. This is not yet done. This is not yet done. There is some temp which is storing nothing, and a blank new node has been created, of which memory address is 2000 by this code. Now what do you want? You want that temp variable to point towards this node. Okay, that means you have to store here 2000. How is that possible? So to make temp pointing towards the new node, what you have to do, in the left hand side, you have to provide the identifier, okay, that temp. But as the right hand side is a number which is, let's say, 32 or 48, an integer value. That is an integer value, the memory size. Okay, so to convert that value into the memory corresponding memory address of allocation, you have to typecast explicitly, that is like this, and here you have to provide the struct SLL node and star. By this, the address returned by the malloc, okay, is being typecasted into a value which can be assigned inside temp. So this code is basically 2000. So temp is like equal to 2000. Then only here 2000 is stored, so that temp is pointing towards this node, not the data part only. This is pointing towards this node, overall node. Okay, so by this single line we can do this. We create a new node and make some pointer to point towards that. Now it's about, okay, so temp is a structure pointer. Why? It's a pointer pointing towards a node, which is itself a structure. So it's a structure pointer. So using this structure pointer, temp, yes.
Sir, what is
Yes.
typecasting?
Hello, please louder.
Sir, what is typecasting?
Typecasting means, typecasting means to convert from one data type to another data type. Let's say I have a value 5. Okay, okay. For example, we have a value 5.25, but I may want to convert that 5.25, which is a float data type, into another data type, let's say int. Okay, then you can do that. Typecasting is a method by which you can convert a float data type into any other data type, let's say int, like that. So these are of two types: explicit data type, explicit typecasting, and implicit typecasting. So in implicit typecasting, typecasting is being done internally. You don't have to do that. But explicit typecasting, here this is an example of an explicit typecasting where you have to explicitly, okay, write some code, proper code syntax to typecast the existing variable of one data type to another data type. Yes. Any other?
Okay, sir. Okay, sir.
Okay. So this is done so far, right? Now I want to access. So this structure is having two elements: data part. This is the linker part. So to access these two parts, data part and linker part, using temp pointer, how is that possible? So let's see that. Okay, so using the temp pointer, we want to access the data part and also the linker part, which are the elements, who are the elements of the structure or node. So let's see. So temp, I have to use a arrow operator. This is arrow operator. So there are two operators. One is dot operator, another is this right arrow operator. So using dot operator also, you can access structure elements. What are the structure elements? Is data and linker. And also using arrow operator, you can also access the structure elements. Dot operator is used for structure variable, and here temp is not a structure variable, it's a pointer, structure pointer. So using structure pointer, if you want to access the structure elements, you have to use this right arrow operator. So write a temp, we pronounce this right arrow operator as pointing to. So temp pointing to, or simply pointing. So temp pointing data. So if I write this code syntax, temp pointing data, that means with the help of this temp pointer, I'm more specifically able to access this data part. I'm going inside the node and accessing the data part by this code, temp pointing data. Similarly, if you write temp giving a space, okay, you may not provide any space, it's not a problem. So temp pointing linker. Linker is the variable name of the pointer. This is the variable name, linker. So temp pointing linker. So if I write the syntax, okay, with this, I will be able to go inside the node and access the content of this linker part. So this is how we can access the structure elements called data or linker part. Okay, fine. Understood, I hope. Now if I provide so if I at this moment, if I do this, the temp pointing data equal to 2, what will happen? What will happen if I provide that? So using temp pointing data means this location inside this content, data part content. So I am assigning a value, let's say 2. So this will be done by this simple line, temp pointing data equal to 2. Okay. Or if, okay, and if temp pointing linker, so temp pointing linker, if I provide, if I write there null, null, so then what will happen? Then here 0 will be stored. Null SQL is 0. So 0 will be stored. That means pictorially it is now pointing towards null. Understood? So this is the happening by this 3 line. So now already we have a node, only node in the linked list, and first node is have to point towards this newly created node, okay, which is added at beginning. For example, in our case, earlier the list was empty, so it is regardless of the position where you are going to insert, it is insertion at beginning, insertion at end, whatever. So yes, as the list is empty, wherever you are going to add, that is insertion at beginning, right? So then whenever you are doing insertion at beginning of a new node, first should be modified. Okay, so here first earlier was pointing towards null, now it should point towards this node. So how can I do that? So that means inside first, it should not be null now. It should hold the address of this node. What is that address? 2000. So I want to put there 2000. Now how can we do that? 2000. Do I know the address of this node? No, I don't know. Who knows that? See, this temp variable knows that information, the address of that newly created node. It is because it is holding the address of this newly created node. So I have to copy this value of temp inside the first pointer. So the syntax will be simply first equal to temp. That's all. So by doing this line, writing this code, we will be able to establish this connection. So once this red connection is established, the black connection will be lost. Right. And see, after successfully inserting a node at beginning, when the linked list was empty, the diagram looks like this. And for doing that, this is the simple code, 4 line of code. Okay, so it's already 11:27. So let's stop here, and I'm providing the short quiz 6. You finish it by there are 5 questions. So I will be giving only 5 minutes. I think it's sufficient. Very informative question. If you know, you can answer that in a second. So 5 minutes and 5 questions. And I wanted to show you the code implementation of this, what we have discussed so far. But yes, time is only 11:27. So let's stop the class, and I'm giving you the link for the short quiz 6. If you have any doubt, you can ask me. Thank you for listening to the lecture.